Ty, what's a state function?
It only matters where it starts and where it ends.
It only matters where you start and where you finish. So for a chemical reaction, we're only concerned about the energy change from the starting point to the finishing point. Doesn't matter if the reaction occurs in 1 step or 5 steps. And if we know where we start and where we finish, we can use completely different reactions to figure out our enthalpy change, as long as their starting point is the same and our finishing point is the same. I call these Hess's Law Problems. And they're not hard, but they're a little bit tricky, and you probably will see one on an AP exam. So we're going to go through this. This question is, calculate the standard enthalpy of formation of CS2 given those 3 reactions. So the equation for when it says formation, that means the formation of that compound from its respective elements. So the first thing we're going to do is write the equation for the reaction that forms CS2. So we got graphite and sulfur reacting to form CS2. That's balanced. Okay? It has to do with the arrangement of the atoms, shape. Okay. So we're going to use these 3 to figure out this one. Completely unrelated. But we can arrange these so that our starting point is the same as this, and our finishing point is the same as this.
Great.
It is great, isn't it?
I don't think so.
Because enthalpy is a state function, we can do that. You don't think it's great?
No.
Okay, look, it's a great thing. It's beautiful. Like what?
Unlike most of us.
Some of you have potential. Good potential or potential to do great damage? Just potential. You know what it means when a coach says, my team has a lot of potential? They suck right now. Yeah. Coach speak. Okay. Are we recording? All right. We got carbon over here as a reactant. So this equation, this is our starting point, right? We can do one element at a time. So this first equation has carbon as a reactant. I like it. We might be able to use it. We also need sulfur as a reactant. This one has sulfur as a reactant. That's cool. I like it. We can probably use it. We need CS2 as a product. None of these have CS2 as a product, do they? That's no bueno, but we can fix it. We can work around it. Here we have CS2 as a reactant. So we're going to flip that. There's no law against it. We are allowed to flip it. So we're going to flip that one. What happens to the value of my delta H? We change the sign. So this is going to be positive 1072. Okay?
Wait.
What? I heard a question. If this reaction, written as is, has a delta H of negative 1072, then the reverse reaction will have a delta H of positive 1072. So I'm going to flip this one so that I have CS2 as a product. That's where I want to end up. I want to start here, and I want to end up here. Okay? So the first one is good. That gives me the graphite where I want it. See it? Yay. Next I want the sulfur as the other reactant. Yay.
Why would you multiply by 2?
Why am I multiplying by 2?
Oh, that's
I need 2 of them.
the stoichiometry.
The stoichiometry. I need 2. This only had 1. So I'm going to double it, which means I'm going to double my delta H. Yes. Yes. It has to match. If it doesn't match, then it doesn't work because the enthalpy of formations are different. Okay, last thing. We flip this one around, and we end up with CS2 as a product. Change the sign on our delta H. I know it's kind of hard to see. Now, to make sure this works, we have to start canceling things. Make sure it adds up to what we want it to add up to. So, start canceling out. I have 2O2 and 1O2. That cancels out these 3O2. Or anything on the reactant side that also appears on the product side cancels out. So then I've got, what else do I have that cancels? CO2 cancels CO2, and SO2, 2SO2 cancels 2SO2. So when you add them up, I end up with this, which matches this. So now I can just add up my delta H's. And I get 86.3 kilojoules. Any questions?
When we're given problems like this, we're always going to give like 1 or 3 above that.
You'll be given 2 or 3 or 4 reactions, and then another one that you're asked to find the delta H for. And you use the ones that you're given, arrange them however you have to, and then cancel out, and then add up to find the delta H for the one that you're asked to find. Now,
Why didn't you, okay, you know when you add the given reactions, why is it 2S and then 2O2 and then 2SO2? Where did you get that from?
why is there 2S?
Yeah. Like there's only one on the very top.
Because
I doubled it.
C plus 2S, it doesn't be right. Like in the actual one, so 3 times 5
Oh, okay, that's the part 1 then. So you-
I have to match this. 1 carbon, 2 sulfurs. So if I'm using this, I have to double it so that I have 2S. So this got doubled. So the delta H also got doubled. I got to make the coefficients match. Any questions? All right. Another problem on the board. I'm not going to help. Choose someone to come to the board, and then you can, the rest of the viewing audience can assist them. Just looking for a volunteer, whoever caught it. That's kind of lame, Ty. Okay, calculate the enthalpy of this reaction. Okay, so we're combusting some carbon to produce carbon monoxide, and we're going to use these 2 equations to figure it out. Because we've got delta H's for these. So, all right. I'm done helping.
Cody, can you start for that?
Calculate the enthalpy of this reaction. Yes.
No, your clue. Yeah.
Why are we flipping that one? I want CO as a product. Very good.
Are you mute, Cody?
Yeah.
Are you what?
Mute. You wouldn't even pull it out of his life.
What happens to the delta H? Why did we just lose a sig fig? I think there should be a law of conservation of sig figs.
6 weeks can be created in
Let's erase that middle one so we're not confused by it. Since we just flipped it, we don't need it. Why am I still helping? It's my job.
Yeah.
Wait, I don't have. I just
Not bad.
He's got it flipped right there. If you don't have it,
Flip it again.
just flip it.
Yeah. Yeah.
Okay, watch your language.
And then O2 both cancel.
Only half of it though.
You have to multiply by
Okay,
two.
what are we doing now? CO2 canceled CO2.
But does O2 actually matter? Because it's O2. It's most
The equations have to,
well,
the equations have to match.
so
It doesn't matter for, its entropy of formation is 0, but the equations must match.
that just depends on what happens.
Is that an S or a G? It's a.
Yes, quite obviously.
Are you sure? It looks like a G. It looks like all of the G's.
So
Clearly there's a difference.
Okay. You sure?
Yes.
maybe
So now add them up. Let's do it right. Draw a line under it. Add up everything that didn't get canceled out.
Wait,
or is it CO solid? Is it
Does that match the equation that we're trying to find entropy for?
yeah.
Okay, then
It's
add up your delta H.
add it or
Addition.
alright.
Find the sum.
282.
Plus sum.
I thought you were helping. You weren't helping.
I'm helping a little.
It's hard to
Negative 110.
Yeah.
His handwriting's pretty good. It's almost as good as mine. Half of it did.
Oh.
But still, it don't matter because that happened.
Yeah.
Questions? Here there was a half, right? And here there was a whole. So he canceled it out, left him with a half. Huh? Do I need to put it back on what to begin with so you can see? To begin, what'd you do with my marker? Okay. This was just O2. This was 1/2 O2. Okay? So this 1/2 cancels half of this, you end up with 1/2 O2. What? No, that's a gas.
So,
Gas. Gas.
Well, I guess it's CO, yeah.
So it matches. Questions? All right, you need practice.